Hi students! So we are one chapter done in our Psych 218 course. That is Analysis of Behavioral Data. So we finished Introduction to Statistics, Chapter 1, and we're on to Chapter 2, Frequency Distributions. And we come to this chapter because after understanding and describing why we do statistics and what is required to do statistics, including variables and data. And we started gathering the data and adding up the data to include the scores of our participants, whether it's a sample or population. We need to organize and summarize those results. And the way we do this in statistical procedures is frequency distributions, is to organize the data so that researchers and people like you and me can look at that data and go, oh yeah, I see what he meant, what she meant when they talk about the average, or when distribution is like symmetrical or positively skewed or normal, quote unquote. And so this applies to things you've already heard about in your studies, like the bell curve. The bell curve is a frequency distribution. There are perhaps the course is too easy, and then you get a negative skew where there are more scores piled at the top end, higher marks, and then there's only a few people that didn't do so well. It looks like a tail when you look at the frequency distribution later on. Or of course it's too hard and the scores are piled at the negatives or at the left side of the distribution, and then you get a right tail. So if these sort of distributions are new to you, this is what we'll be exploring today. And this applies to, things that we do every day, whether it's studying or whether it's again, it could be body temperatures, sleeping hours, money we spend. Because we do things differently and have different results, we're going to have a distribution of scores. And frequency here is how many people scored a certain value. Moving on. So there are 6 learning outcomes this time for chapter 2, and there are 6 things that we want to do by the end of this chapter. So again, what I recommend in our classrooms and in these videos is that use a textbook for sure. The lecture slide is like a person explaining to you how things are done, but that is absolutely no substitute for you doing the questions and applying the concepts. So here are the 6 things. This is a checklist of 6 things that we want to do if we want to say, yeah, I know about chapter 2 in frequency distributions. 1, we want to be able to describe how frequency distributions are used. Now, we already talked a little bit about that, but we'll go into this in more detail. 2, we want to be able to organize the data into a frequency distribution table. So from last chapter, we have started, gathering the data and adding them up. Now we're going to organize them. If we want to do group frequency distribution tables, so you also want to learn to organize that as well. Now, a difference between frequency distribution and group frequency distribution is that if you have scores that are fairly low range or small range, like 1, 2, 3, 4, 5, 6, it could be the number of courses you're taking, for example, and you only have so many or so few, then you only have one value per category. And that's not the same as a group frequency where, for example, if there's a 100% from 0 to 100 in your course grade, then it would be really, really hard to include all 100%, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on, and graph that. The graph would be huge. So often what we do is we group the percentages. It could be 0 to 9, 10 to 19, 20 to 29, and so on. And in a way, your letter grades A, B, C, D is sort of a group frequency distribution. Once you start grouping people into letter grades. So there's a difference between organizing data in frequency distributions if the values are simple and small, and that's different from a group frequency when you have a large set of values and we probably need to group them together. There are ways to do that. Number 4, we want to be able to explain how to look at and read and interpret, that means to talk about, these frequency distribution, be they quote-unquote regular frequency distribution or group frequency distributions. Number 5, we also want to organize the data, not just in frequency distribution tables, but also frequency distribution graphs. So those would be our histograms, our bar charts, and frequency polygons. And we'll see a lot more of the frequency polygons for the rest of the term. And that's where you get the curves, including in light of 2020, the COVID event, flattening the curve. That is a frequency distribution graph, specifically a frequency distribution polygon. So, except there's so many points, it looks like a curve. And we'll talk more about that. And there are ways to organize that data into graphs. And finally, we want to be able to explain how to identify and interpret those graphs as well. So those are the 6 learning outcomes for this chapter. In the last chapter, we split the chapter into parts, and we went at a fairly comfortable pace. If that is fast for some of you, you're welcome to take breaks within the video and follow the parts, as in it could be 1.1, 1.2, 1.3, and break those from there. For this video, we will go a little faster and complete the video in one big part in 1 hour. But what I really strongly recommend is watch this video more than once. Watch it in parts and divide the video in parts where it's 2.1, 2.2, 2.3, and so on. So I would give you some verbal reminders to give you a chance to take a break if you need it. If you are the type that wants to just listen all the way through, you're welcome to do that as well. So let's get started. So again, the math tools you need for this chapter are some things that you already have, not only in your previous courses for math, but also what we talked about in the last chapter. We would need the following tools. You would have proportions, that is to deal with fractions, which also includes decimals and percentages. So this will be useful in our frequency distribution tables. You also need to apply the stuff that we learned from the last chapter about the different scales. Nominal, remember name, ordinal, think order, interval, and ratio. Interval is the one that doesn't have an absolute zero value. It could be arbitrary or no zero. And ratio does have an absolute zero value. We also want to be able to distinguish between continuous and discrete variables. Continuous, think decimals. Discrete, think integers. And you can go back to chapter 1 if you need to review these types of variables and scales of measurements. And finally, the concept of real limits and how we get the real upper or real lower or upper real or lower real limits. That's going to apply in our continuous variables as well. Close that. So first thing, what are frequency distributions? So if you've ever, worked with numbers, it could be like the courses you're taking or the tuition that you want to spend or your budget. If you have to put more than one number for more than one category, and you could be writing about how many dollars you're planning to spend for something, you are working with frequency distributions. So in that sense, distributions of frequency, and frequency here is score counts. So I'll give you an example of this. What this means is, for example, if I had a course and I group the students by their percentage, and based on that percentage, the system would say that person had an A category. It could be A minus, A plus, A, B, same thing, C, same thing, D, same thing, F, same thing. So let's say, for example, 3 people had an A in the class, 6 people had B's, 9 people had C's, 6 people had D's, and 3 people had F's. So each time you counted something, you are counting what that person scored, and you are doing score counts. You are counting scores. Each one of these is a person that had a particular score. So it would read like this: A, B, 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 C, 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 D, 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 F, F, F. So already I am drawing and showing you what frequency distribution looks like. And this would be a way to show the points that you see in the outline. Frequency distributions are organized tabulations of data, and they show the number of individuals located in each category. So here you would have the category, and in your textbook and your lecture slides, you'll see, oh yeah, wait a minute, that's X. F stands for frequency, and you'll see that again as well. And then you can actually write numbers for these: 3, 6, 9, 6, 3, the same thing as well. So these are all frequency counts, okay? It can be either a table or a graph. So first we're going to show you the table, and then we're going to show you the graph. This would be sort of the table right here with the numbers. And this one that looks more like a picture, and it is, would be more like the graph. And I'll show you this, different ways of graphing the same data from the frequency distribution table. We always show the categories that make up the scale. In this case, the categories are letter grades based on percentages. And we always show the frequency of the number of individuals in each category. So that is, for each category, we have to count whether there are participants in the group that had that score in that category. So it's like saying, did anybody get A's in that class? Or did anybody fail the class? And whatever number you give answers that question. And that's showing the frequency. And that's what we're talking about, score counts. Having said these things, the next few slides, if you understood so far what we're talking about, would be a lot easier for you. So let's go through the next couple of slides. So here are the instructions and structure of how to make frequency distribution tables. Think of this slide as a checklist. You'll have the first column, which is a category, and you'll have X like this. This would be column 1. I can't spell column. There you go. C-O-L-U-M-N. And then column 2, you would have the frequency count. Think score count. Okay? So you have X and F, and we'll talk about how to order the categories in a minute. And then we have notations for adding up the scores. That is also not only adding up the categories, but we also actually count all the scores. So for example, if we assign values to these, like A, B, C, D, and F, and we assign them based on their rank, 1 here being the lowest. I'm not thinking first, second, third right now. I'm thinking the 5th highest rank. Okay, so that's something I'll remind you again. When we do frequency distribution tables, the highest rank, the biggest number, goes at the top, and the lowest rank goes at the bottom. Okay, so don't get confused about first, second, third, like in a race. or competition, think the biggest number goes at the top and the smallest number for categories in column 1 goes at the bottom. Okay, so if the person who had an A is 5, the 5th highest rank, and has a score 5, being the better student, quote unquote, if there are 3 students, and I'll write the same numbers again. Okay, this is not 3, this is 6. 3. Okay, so we would actually count the score. So there would be, remember how we wrote A. So that would be 5 times 5 times, 5 plus 5 plus 5, which would be 15. Okay, so again, you can take a moment and figure out how many people got B's, and if B equals 4, what is 6 times 4? So that would be 24, right? So that would be our column like this. So when we show you the frequency distribution table, and you will see this in your textbook, you will need to do these additions for specific things. For example, you would want to find later on in other chapters average, and that is the mean, and also sums of squares. So we'll talk more about that later. But again, for the frequency distribution table, there, your checklist, the first thing is you need 2 columns. The first column is categories, and the second column is frequency count. Remember what it said here. The order is usually from highest to lowest. Okay. In this course, we want to follow that convention. So I will remind you now and give you a sort of a brief warning. We have seen students that do the opposite. 1, 2, 3, 4, 5. We will deduct marks for this class. Okay. Some instructors would not mind as much, but for this class, I want us to follow this convention. And so I would tell you with fair warning that, yeah, we would want to follow this convention and have the categories from highest to lowest. Okay. If your other instructors in other courses don't do it, hey, lucky you. You can, let go of that convention for those classes. Okay. And the second column would be the frequency count. These are different things, different columns, different values. Let's keep that in mind. So once you have started, your frequency distribution table, you can start measuring things and start organizing the data. And one of the things you can do with the skills you already have is to look at the proportion of the group that had a certain score. So this would answer questions like, oh, okay, back to our course. Let's say if there were 3 plus 6 plus 9 plus, I'll actually write this down so I'll give you an idea. So if in the class, and I'll write this frequency again, distribution. Okay, so A, B, C, D, E, F. There's no E. So 3, 6, 9, 6, 3. So there would be a total here. Okay, and take a moment and calculate that. Oh, 27. Pretty easy, right? So, double check here. Yep, 9 times 3 is 27. Good. So, you might ask, okay, if there are 27 students in the class, in this particular class you're looking at right now, or you can think to your class, oh, there's 34 of us. If half of our class passed the class, that would be rather bleak, but, let's pretend. Then 50% of the students pass the class. Just like if we look at this chart and we go, oh, 3 out of 27 people had an A. So then you can divide 3 by 27, and that will give us a proportion. So again, F would be whatever score you're interested in. In this case right now, it's A. Students that got A's. So it'll be 1/9 or 0.11 or just 0.1 recurring should be. So those are the proportions, and there will be about 11.1%. I'll put the approximate thing there instead of equal because it's not 11. It's approximately 11%. So we can start organizing the data and describing them. And one of the things we can do is describe them in either proportions, which you can use this technique right here. Just look at the one you're interested in, count the number of people that had that score, and then divide it by the total number of people. N here is the total number of, population or sample. And to convert that fraction or proportion into a percentage, multiply the proportion by 100. The proportion would be no greater than 1 and no less than 0. So then you will still have your 0 to 100% respectively, depending on what the proportion is. So let's give this a try. Here is another frequency distribution. Now, notice the next slide already has the answers, but if you want to practice, even if you already knew the answer, try it out and write it as fast as you can if you know the answer, following the work, and this will be good practice. Again, if you already mastered basic math, this should be really fast. Do it at least once so then you know you've done it. But if you had trouble with this, doing this a few times would definitely help you through. So notice here that you can first figure out the total, and that is basically all the F's. So here would be 1 plus 2 plus 3 plus 3 plus 1. All right, that's 10. Yeah, 1 plus 2 plus 3 is 6 plus 3 is 9 plus 1 is 10. Okay, so you know there are 10 people. And if we were to follow the math, okay, so here we're not actually dealing with x's at this point. We're dealing with the frequency counts. So we know the total is 10. So basically we can do divide by 10 each time. So that's one neat trick. You know the formula is the same for each one, so you just kind of plug in the values. Yes, but we are working with particular counts. So 1 out of 10, 2 out of 10, 3, 3, 1. And some of these we can simplify, right? So in terms of percentage, well, I can multiply by 10. So multiply by 100. And we can do this. And if you know your fractions, you can cancel out, of course. So this would be 10%. And I'm going to skip a little bit of the math. 20%, 30%, 30%, and 10%. Now, you might start to notice something. I'm going to erase this part. If you add up all the frequency scores, you'll get n. So we talked about that, and we showed that. If you add up all the proportions, like 1 out of 10, 1 tenth, 2 tenths, and so on, all the way to the last one, you'll get 10 out of 10, or 1. Just like if you add all the percentages together, it will be 100%. So a good check for this, when you have a test question or quiz question that asks you to make a frequency distribution or to, describe it and interpret it, there's several things you want to check. One, you want to be able to add up all your frequency counts to get the total size, whether it's sample or population. Two, if you start doing proportions or checking proportions on it, the proportions would all add up to 1, or the percentages would all add up to 100. So keep those in mind as you make the frequency distribution or start interpreting them, and when you include proportions and percentages. So this is the answer key. So first, learning check. Here's one with a frequency distribution table, and you can practice looking at it. The question 1 reads, use the frequency distribution table to determine how many participants were in the study. Is it A, 10, B, 15, C, 33, or D, impossible to determine? You can pause if you like and do the calculations, or You may have calculated already. And the answer is 10. So remember, you're counting from one of those columns, and the column you want to count with is the frequency column, not the category column, not the first column, but the second one. So 2 plus 4 plus 1 plus 3. 6 plus 4 is 10. So there you go. If you did other calculations, you would not be counting the number of participants. There are other things you got to do, but we're going to cover that later on. Next is the true-false. It's two parts. A, more than 50% of the participants score above 3. True or false? And B, the proportion of scores in the lowest category is 3. Here you might want to pause the video or take a moment and do the proportions. So for example, you might want to do one that is the proportion and one that's the percentage. You probably might want to write the formula if you're stuck. Okay. And you may be able to do it in your head, but again, like I recommend to all students, no matter how great they are with their math, unless they're geniuses, I suppose, writing the work on paper always reduces your cognitive load, as in you're not keeping as much stuff in your head and you can work on it on paper. So quickly now, so again, we need to do the total first, and we know it's 10. So we have 2 out of 10, 4 out of 10, which we can simplify. 1 out of 10, 0 is just 0. 3 out of 10. We don't need to simplify the 3 out of 10. 1 out of 5. 2 out of 5. That's it. So we have 20%, 40%, 10%, 0, 30%. So if we see how many people scored above 3, we take 4 and 5, and the percentage is 20 plus 40. And I'll leave it to you to figure out if that's more than 60. Now how about B? Is the proportion of scores in the lowest category 3? Now remember, it's proportion of scores. So if we've already done the proportions, and we think back to what it means to calculate proportions, and even if we add up all the proportions, there's a maximum number that proportion could be. And we can compare that with this value to see if that's possible. So let's take a look then. If you answered true for A, and you did the work and checked the work, just like we had in the previous slide, it would match. So yes, you have 10 in total. So that's 20% and 40%, which is 60%, which is larger than 50%. So you can say more than half or more than 50% of the participants had a score that is higher than 3. So that answers the first one. 2, the proportion itself can never be larger than 1. And again, it can be no less than 0 either. So the proportion would be a fraction. In this case, it would be 3 over 10 or 0.3. Next, we're going to do group frequency distributions. And just like we introduced in the first slide about the difference between regular quote-unquote frequency distributions, where the categories are just 1, 2, 3, 4, 5. Group frequency distributions is when the number of categories are very large, we would combine the categories, so then the table itself is easier to understand. So to give you a quick picture of this, you know, instead of 1, 2, 3, 4, 5 in our X, if it was really big, it would be 100, 99, 98, 97, 96, 95, 94, 93, 92, 91, 90, blah, blah. 0. Yeah, you can see this table is going to be very, very hard to read. And it's going to be very, very long. So you might group them to say 90 to 99. Wait, there's no, depends. Okay, so we could do that. 0, 90 to 99, 80 to 89. I can't write. 70 to 79, all the way down to 0 to 9. So again, when we group the categories together, we make the table easier to read. Now there are advantages to and disadvantages to this, and we're going to explore that. And we'll start right here. Remember, if you had the first virtual class and we talked about this, this will be one of the highlights. And the first major disadvantage in comparison to its advantage where you can now actually read the table if the categories are very many, the number of categories is huge, like, I don't know, 100, 200, and so on. You can no longer get individual scores. That means if I kept all the individual numbers in 0 to 100 and just divide by 1, let's say, oh, somebody got 92%, and somebody got 91%, and somebody got 90%. If I kept the individual values, I can say one person got 90%, one person got 91, one person got 92. Just to make it even better, I could say, oh, one person got 98 and one person got 99, let's say. Now, if I were to group the frequency distribution, all 5 of these scores, 90, 91, 92, 98, and 99, they would all be included here. So all I can say is in the group frequency distribution is that, oh, in this case, for the 90 to 99 range, I can tell you from this table, the group frequency table, that, yeah, I can tell you 5 people got between 90 to 99, but if I only read this table, I'll just draw a box on it one more time. If I only read this table, I cannot tell you what exact scores they got. I can't tell you the individual scores anymore. And then, as the intervals get larger or wider, so let's say instead of intervals of 10 points, I go even larger. I go 80 to 99, 60 to 79, 40 to 59. So see here now, instead of an interval of 10, I have an interval of 20, and I group more scores together, more information is lost. And to drive this to the extreme, let's say there's only 2, or even just 1. 1 would be ridiculous. 0 to 100, well, I'll tell you what the whole class, it's like saying everybody in the class got between 0 to 100. Then all the information is pretty much lost, right? One less extreme than that would be, let's say, whether people pass or fail, 0 to 49 and 50 to 99. Well, I'll say like, I could make it up. Half the people passed and half the people didn't. Again, well, what individual scores they had? Well, I can't tell you. These group frequency distributions can no longer tell you that. So there are some requirements and recommendations to making these group frequency distributions. And for this video, I will outline these for you. So we'll start with the instructions first. In terms of requirements, all the intervals must have the same length, or width, I should say. The interval should have the same width. And what that means is, let's say if it was from 0 to 100, I would want to divide these into equal size intervals. It could be in intervals of 10, 0 to 9, 10 to 19, 11, no, not, sorry, 20 to 29. Now notice I didn't do the following: 0 to 10, 11 to 20. Now you'll notice something that's already happening. If I included the 0, this would actually be 11 numbers. 0, 1, 2, 3, 4, 5, so on until 10. That's actually 11 numbers. And then here, 11, 12, 13, all the way to 20. That would only be 10 numbers. So they must be equal. So that's the first thing you want to keep in mind. The next thing you want to keep in mind, and this is a reason why I took a little extra time writing these numbers, is that the bottom lower number of each interval must be a multiple of the interval width. So if I decide to divide the interval by tens, let's say for a number of 100 categories, that's why I wanted to keep it, the bottom numbers is 0, 10, 20, 30, and so on. I did not go 1, 11, 21, 31, and so on. Because 10s and 20s and 30s and 0 are multiples. Yeah, 0 is like 10 times 0, which is 0. Anything times 0 is 0. But 11 is not a multiple of 10. Neither is 21 or 31. Again, so keep that in mind, which is why it might look strange at first. But you want to follow these two required rules, mandatory. First, the intervals must be the same width, so you got to figure out that by counting the number of categories. If they're big, it could be 20, 30, 40, 100. It could be some less regular number like 66. So then you might divide it by 6 and get intervals of 11, or divide it by 11 and get intervals of 6. But then once you figure out the width, you stick by that width and do the bottom number first. And the bottom number needs to be a multiple of the interval width. So if your interval width is 10, then all the bottom numbers of that interval would be a multiple of 10. It could be 0, 10, 20, 30, 40, and so on. And then for each interval, you add the next 9 numbers up. So it will be 0 to 9, 10 to 19, 20 to 29, 30 to 39, and so on. So technically, it wouldn't be 0 to 100. It would be 0 to 99. And if you think about this further, your percentages would be actually 101 numbers. 0 counts. And there are students that score 0 by, giving up or just not attending class. And nobody's gotten 100, but it is a possible value. So something to consider. But these are the rules we want to use for group frequency distributions. Recommendations are, when you divide the groups into intervals, make it 10 or fewer. So a number like 100, well, that's pretty easy. Keep it 10 times 10. If it was 60, you could divide by 6 if you like, or divide by 10 and get intervals of 6 or intervals of 10. Just 6 of these intervals of 10. Choose a simple number for the interval width. Simple numbers would probably be 5, 10, not 15, 20, 40, and so on. Round numbers are generally better, and they're usually in the tens. Next, you would want to adjust the number and width according to the situation. And you would do that by first figuring out how many numbers there are in the categories first, and following the rest of these guidelines and recommendations. For discrete variables in frequency distributions, for each category, they have exact scores because the variables are discrete. There are no halves, just like we talked about. Next, in terms of the individuals, yes, you can include, and you should include, individuals that got the same score in each category. So here's an example. Again, back to our example of A, B, C, D, and Fs. These would be discrete variables now because there's nothing really in between. Let's put all sake and all 6 and purposes. Nothing between A and B. I know you're thinking like A minus, B plus, but for now, for all intents and purposes, let's pretend there isn't. So then, you know, you can have 3 people that got an A, be it A minus or A plus or A. 6 people could get B. 9 people got C. Again, 6 people and 3 people. So we count the individuals and the scores are exact, as in, well, for the category, A, B, C, D, or F in this case. We can use discrete variables for frequency distribution tables, and there's a particular type of graph that we use for this. And we can also group these frequency distribution tables together, or we can make group frequency distribution tables with discrete variables if we choose. Again, this could be integers, like the number of people in a class. Class size, for example. You could have a class size from 0 to 10. Now, I'm not talking about the intervals here, and I have to be a bit careful. It could be 0 to 9, and I can group these again, just like that. Again, I'm saying discrete here because you can't have half a person in the group. Again, you can do the same thing. So I'm just going to follow the rules as usual and do the same. And so on. Let's say class size is about this. 30 to 39. Okay, this would be class size. And that would be possible. And we can have like, there are 3 classes that is really small, 6 classes that is a little bigger, more classes that is about this size, and then a few classes that is really, really big. Again, you can do the same frequency distributions, both the regular individual frequencies and group frequency distribution tables with discrete variables too. For continuous variables, the scores themselves represent intervals, and that's when we apply the real limits. That is your upper and lower limit. In this case, you'll see pictures of this in the histogram, but I'll just write and show you. So, for example, if I had a question where you can get part marks for it, and it's just out of 5, and 5 is being the quote-unquote perfect score, and for this one I'm going to say it's continuous, so you can get something like 1.1, 1.2, and so on. Then these values right here that I'm circling right now, these are actually rounded middle numbers. And what that means is I should include a 0 because you could get 0. It is possible. So in this case then, since there's no negative numbers, this is a continuous ratio. Continuous variable on a ratio scale. So, for example, a person would score 0 because there are no negative values for this one. So between 0 and 1, the real upper limit of 0 would be 0.499999999. Okay? And for the real limits of 1, you would have 0.5 to 1.499999999. So if a person was recorded with a score of 1, quote unquote, on a continuous scale, let's say there are 3 here, that those 3 people would score somewhere in between 0.5 and 1.499999999. So you can take a moment and think about this, draw a scale if you like, and figure out the limits on the continuous variable in this ratio scale. There is no negative value here, so 0 is just between 0 and 0.4999999. So again, remember, when you are dealing with a continuous variable in a frequency distribution, the numbers you see are actually rounded middle values. That's what this is about. And there are real upper and lower limits. Again, that's half of the interval above or below that number, that rounded middle value. Usually you would get values that's like 1, 2, 3, 4, 5. So the interval is 1. And so the limit would be half that distance above and below, as we talked about in the last chapter. Okay. Again, the same applies for group frequency distribution for continuous variables. One thing you want to remember here is that the apparent limit for these group class intervals is always 1 unit smaller than the real limits of the group class interval. Now, we will not be covering the group frequency distribution for continuous variables in too much detail, but these are the instructions for that as well. So again, remember the group frequency distribution do represent intervals as well, and the groups of scores are now actually groups of intervals. So, and the last thing is that these apparent limits would be always 1 unit smaller than the real limits of the group class interval. So for us to check if you understood this, and for us to try one more time and looking at group frequency distributions for continuous variables, here's a learning check that will help us tie in here. The question is, a group frequency distribution table has categories of 0 to 9, 10 to 19, 20 to 29, and 30 to 39, just like we worked with in this chapter so far. What is the width of the interval from 20 to 29? Again, you might go back to the previous slide and look at the rule. And it says the apparent limits of the group interval is always 1 unit smaller than the real limits of the group class interval. So take a moment and think. Now, before we show you the answer, remember how the upper and lower limits work. So, remember the scale that we had. So, 0, 1, and so we have half of that, so that's 0.5. And so we can do this 1.5, so and we keep going 2, all the way up to 9. And so here you have 8.5, 9.5, 10, and so on, all the way up to, and this will be 10.5 is the halfway point. I'll make the actual numbers larger or have longer lines. And then here's 19. And then so the upper limit of 19 would be 19.5. So because even though the frequency distribution tables are grouped, you know there are groups of ones like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on. So you can still get the real upper and lower limits that way. So again, remember what we said. According to the rules, the apparent limits of the group class interval, the interval that you see here, the width of this particular interval that you see, that's why we use the word apparent, is 1 less than the real limit. So here, if you count 20, 21, 22, 23, 24, 25, 26, 27, 28, and 29, there are 10 numbers in there. So that's the width of the apparent limit. However, if you use math and count the interval as 20, So if you did it by counting, you count 10. But if you did it with math, 29 minus 20 would give you 9, which is the apparent interval width. It's the difference between the upper number of the interval, the higher number of the interval, and the lower number of the interval. 29 minus 20 is 9. And this is the apparent limit, the apparent interval. But as you'll see, and referring back to the rule here, the apparent limits, The real limit is one more than the apparent one. So here you see the upper limit of, let's say, 29 is 29.5, and the lower limit is 1/2 of the interval between 20 and the one number down, which is 19, which is 19.5. So if you subtract 29.5 from 19.5, you'll get 10. That is the upper limit minus the lower limit. And that is what we're talking about in this slide. Might sound confusing, but when we actually do the frequency distributions and we want to group them properly, it is important that we do this, especially for continuous variables. Next question. Again, 2 parts, true, false. A, you can determine how many individuals had each score from a frequency distribution table. Notice it says frequency distribution table. B, you can determine how many individuals had each score from a group frequency distribution. You can pause it if you like, or you probably would figure out the answer to these questions by now. These are concept questions, and you probably know it. It's a lot quicker than the last one. For a frequency distribution table, without the word group in it, that talks about individual categories. So each score is individual. They're not grouped together. So yes, you can get the original individual scores. Once you have a group frequency distribution, you cannot. So because the scores are now clumped together or grouped together, if you only look at the group frequency distribution, you can't tell anymore. So it would be false for B. So that's it for this part. I wanted to do all in one part, but it's already about an hour. So this would be about 2 hours for chapter 2, it looks like, because there are quite a few more slides. But I would rather do this thoroughly for us, including myself, and so then you would be more prepared, especially if you are a student that learns better by listening and watching. Again, still not a substitute for reading and working from the textbook, but if you learn better that way, it is better to take this slowly. So we have just finished 2.1, 2.2, 2.3, and 2.4. I realize I've forgotten to tell you to take breaks, but if you have reached all the way up to this point, I would remind you that if you were to watch it again, take breaks from 2.1 to 2.2 and take breaks from 2.3 to 2.4. Okay, so in this part of chapter 2, part 1, we have reviewed the following. We have reviewed what frequency distributions are. We have started organizing the data into frequency distribution tables and organized the data into group frequency distribution tables. So in terms of learning outcomes, we have done the first 3. 1, we have described how frequency distributions are used. 2, we have organized them into frequency distribution tables. And 3, we have done this for group frequency distributions. We've also discussed about the advantages and disadvantages of both regular frequency distribution tables and group frequency distribution tables, as well as how we actually make those group frequency distribution tables for continuous and discrete scales, variables with different scales as well. So there you go. That's it for part 1. If you got any questions about these videos, several ways you can get answers. 1, you can check the textbook. That's available in the course. 2, you can ask me via email. And 3, you can post in the discussion board. So keep going. You can do this. Make sure you spend the time, not just to watch the lectures, because if you just watch and listen and don't do anything else, you probably will forget it. This is a skill-based course, so make sure you work with your textbook and do those questions. That's how you remember. So keep going. You can do this, and we'll see you in the next one.